Hello students, I am Professor Makaran Malpure. Today I am going to give you a brief introduction about unit number 3 quantum mechanics of subject engineering physics. In this unit we are going to study different topics of quantum mechanics such as de Broglie hypothesis, phase velocity, group velocity, Heisenberg's uncertainty principle, Schrodinger's equations, their applications, tunneling effect and quantum computing. Basically, the prerequisite required to study quantum mechanics is nothing but the fundamentals of wave-particle duality we have already studied in 11th and 12th. So the topic of quantum mechanics actually started with wave-particle duality of radiation. So there are two main natures of radiations. We can see wave nature and particle nature. We have studied in classical mechanics in recent years that wave and particle shows different properties as we given them separate treatments. Matter particle is identified by the properties such as mass, momentum, kinetic energy, etc. When wave is identified by properties like wavelength, frequency, amplitude, intensity, and energy, we are already aware about these properties. These are just fundamental properties of material particles. Just like that, electromagnetic radiation is also. The example of electromagnetic radiation is light wave, we can see. Optical phenomena like interference, diffraction, and polarization shows and given by electromagnetic radiations. So from these examples we can see electromagnetic radiations must have wave nature, as these are the examples of radiation itself. Now if we take the example of particle nature, we have photon over here. Phenomena like photoelectric effect, Compton effect, black body radiation shows electromagnetic radiation having particle nature. So this is how we can see electromagnetic radiations must have dual characteristics like wave and particle. That's why radiation is composed of wave nature and particle nature, and exactly it is called as wave particle dual. Next point in quantum mechanics is properties of matter waves, which is another most important topic of this unit. According to de Broglie hypothesis, for a particle of mass m moving with velocity v, the wavelength of matter wave associated with it is given by this formula, lambda is equal to h upon p, which is exactly equal to h upon mv, because p is the momentum and we know that it is the product of mass and velocity. Here one thing we should note that h is a Planck's constant. So there are several properties of matter wave depending on this equation are listed as below. First property is wavelength is inversely proportional to velocity. That means the wavelength of matter waves is inversely proportional to velocity of particle, that is lambda is inversely proportional to v. Thus when particle is at rest, its velocity must be 0, and appropriately it de Broglie wavelength becomes infinity. Smaller is the value of velocity, then longer is its wavelength. It means that matter waves are detectable only for moving particles. Second important property of matter waves is wavelength is inversely proportional to the mass of the particle rather. Lighter is the particle, smaller is the value of m. So this is the meaning of this second property. Hence longer is the wavelength. Matter waves associated with it have large mass. Therefore wave behavior of microparticles will be significant, whereas waves associated with macro bodies, that means the bodies having very large shape, can never be detected. The third important property of matter wave is matter waves are related with probability of finding the particle. If a photon is considered as a particle, then corresponding electromagnetic wave must be de Broglie wavelength of that proton. Similarly, atomic particles are associated with matter waves which do not have similarity to any known waves such as electromagnetic or sound waves, we can say. De Broglie waves are associated with locating the probability of particle and hence also known as probability waves. The fourth property is matter waves are not electromagnetic waves. Any type of wave which is produced by oscillation of certain quantity. When charged particle oscillates, it produces electromagnetic waves. Okay, so this is the generation of electromagnetic waves. Matter waves are produced by motion of the particle and do not depend on the charge of the particle. That's why we can see matter waves are not electromagnetic type of waves. Similarly, in fifth property, We can also mention matter waves are also not mechanical types of waves. Mechanical waves, just like example of mechanical waves is sound waves, which are produced by the vibrations of the particle of any object which is placed in a medium through which that object is traveling. A particle can always travel in vacuum, and hence matter waves are associated with it, even in vacuum. As matter waves do not require any medium for propagation, absolutely they are not mechanical waves.